Unit 10, Lesson 1. I can justify the measure of inscribed angles and their relation to chords. So let's go over the vocabulary. An inscribed angle would be this angle right here. I'm going to highlight it. Notice the vertex of the angle is sitting on the circle, and that's how I remember what an inscribed angle is. The vertex is on the circle. Now, let's look at some other pieces. We're going to go ahead and talk about the intercepted arc. And the intercepted arc, imagine turning the light on if this angle were a light and shining its light. Go down this arm. So from here, go down this arm. From here, if you shine this light, it would hit against this part of the circle. The light would intercept this part of the circle. So this over here is the intercepted arc. Arc is a part of the circle, and it's the part that the angle light is hitting if we were to go down those two arms. This here is a central angle. Notice the vertex is at the center. Right here. And if I were to turn its light on for my central angle, its intercepted arc would actually be the same arc, minor arc BK. And finally, when we talk about a chord, okay, it's a segment with endpoints on the circle. So, for example, segment KH is a chord, segment BH is also a chord. That's the general vocabulary we're going to be working with for this lesson. And one of our goals is to come up with a relationship. And specifically today, for this inscribed angle, how does it relate to the various chords, the intercepted arcs? What can we figure out for relationships? So we're going to go ahead and do a little mini investigation to sort this out. So imagine for a second that the measure of minor arc BK is 140 degrees. So I can come up here and say this is 140 degrees. So I can go ahead and write that down as my given. The measure of arc BK is 140 degrees. That's given to me. Also, segment BH is a diameter. Also given. What can we figure out from that? So let's just start taking a look. If this minor arc is 140, the pink one, I know that the central angle here is also going to be 140 degrees because central angles and their intercepted arcs are the same. So I can come down here and go, all right, well, the measure of angle KLB is equal to 140 degrees. Y, the central angle, is equal to the intercepted arc. Okay, can we go any further? Anything else we can figure out? Well, sure. What about this angle right here? This angle in here we know is, that's right, 40 degrees. So the measure of angle KLH is equal to 40. What's the reason why? You remember these make a straight line and they're adjacent, so that's a linear pair. Okay, we're getting closer to the angle that we're looking for, so we can find a relationship. What's next? This is a little bit of the hard part, but if you notice, segment LH, this guy right here, is congruent to segment LK. Why? This is a radius. It's a chord, it's not a chord, excuse me, it's a segment from the center of the circle to the edge of the circle. That's the radius there. That's also a radius. This is also a radius. Those are all the same. But if I just look at this triangle here, I can see that it's an isosceles triangle with two legs being the same, with this being the vertex angle here. All because this segment and this segment are both radii. So what I can do is I can come in here and say segment KL right here and segment HL are congruent. What's the reason? That's the definition of a radius. Okay, each radius is equal to another radius. And then we made an isosceles triangle, which is great. So I can classify triangle LKH as isosceles. With vertex L. So what's the reason for that? That's the definition of an isosceles triangle. Two legs are congruent. Now, if that's true, then I know that this base angle here and this base angle here also have to be congruent in an isosceles triangle. So the tricky bit is, you know, all three of these sum up to 180. So that means then what do these have to be right there? And if we go do some calculations, if you think of this as like x and x, they're the same. I can write a little relationship down here and say that 40 plus x is equal to 180. So we're just using all these relationships we already know to try and find a new relationship. So I could say that 40 plus x is 180. Take 40 from both sides, and I've got 140, and this is 2x. Divide both sides by 2, and your x is equal to 70. So this right here is 70 degrees, which makes this 70 degrees as well, the two base angles. So I can come in here and say that the measure of angle KHB, which is this right here, my inscribed angle, is equal to 70 degrees. What's the reason? It's the triangle sum theorem. All three angles sum to 180. So that's really important. And once we have that, we can look for an overarching relationship here. Okay. I could have put another line in here, probably skipped a step, saying that these two base angles were the same because it's an isosceles triangle. So I could have said that the base angles were the same. But once we have that this is 70, then I can take a look and compare this green inscribed angle to the intercepted arc. What's the relationship if this is 70 and that's 140? And you can see it in that the measure of angle BHK, my green inscribed angle, is actually equal to the measure of this minor arc, BK, however, divided by 2. It's divided by 2. Half of 140 is going to be 70. So the major conclusion we want to get from this is that the inscribed angle here, its intercepted arc, if you take half of it, you get that angle. So the measure of the angle is equal to the arc divided by 2 is our new relationship. Again, the measure of this angle is equal to its intercepted arc divided by 2. Notice the difference. The central angle is straight up equal to its intercepted arc. But if you move the vertex from the center of the circle to on the circle to be inscribed, now it's half of the arc. So we just used a given number and a bunch of relationships we already knew to figure out this relationship. So if we go and try and apply it now, let's see what we have. First things first, let's make sure we can name what we're talking about here. So if I look here and I want to name an inscribed angle, I could come, for example, to angle GY. So FGY would be this angle right here. Okay, that's angle FGY. Name the inscribed angles intercepted arc. So if you turn the light on, again, this is inscribed because it is on the circle. Turn its light on. What part of the circle will it intercept? And you can see if you turn its light on, it's going to intercept arc FG. Follow down one arm, follow down the other arm. That's where the light would hit. So my intercepted arc would be FY, right here. Let's try and name another one. Let's turn the light on here. For angle Y, specifically we can call this angle FYG. Notice it's the middle letter. That's the vertex, the Y here, the G there. What arc would it intercept? Go ahead and think about it. Okay, here I go. Turn the light on, it's going to intercept that arc over there, which is arc FG. The last one, arc F, angle F, or angle GFY rather, would intercept, if you turn the light on, arc GY. So we need to be able to name them and identify the intercepted arcs for each of these inscribed angles. Now let's go ahead and take that relationship we talked about, which is that this angle is equal to half of its arc, and see what we can do. So I'm going to go ahead and zoom in on this guy here. And in circle Q, so you know the center is Q, the measure of minor arc ST is 68. Let's annotate. Okay, I'm going to use this info. Where is arc ST? S to T is the minor arc. So I'm going to go ahead and put down 68 degrees. Find the measure of angle TRS. Let's go find TRS. TRS. So that's this angle right there. That's TRS. We also want to find SPT. SPT is this angle right there. Now, if you notice, what kind of angles are these? Are they central angles? Are they inscribed angles? Well, they're inscribed because the vertex is on the circle. Okay, so these are inscribed angles. And the relationship we know is that this angle here, for example, is half of its intercepted arc. So shine its light, and it intercepts this arc right here. So the measure of angle R is equal to half of this. So the measure of angle R is equal to half of 68. And half of 68 in this case would be 34 degrees. But what about the measure of angle P? Well, shine its light, and notice it intercepts the same arc. This is kind of a cool thing that can happen. It's like a little puzzle. These two inscribed angles intercept the same arc. So the measure of angle P, in this case, is going to be equal to half of 68, half of its intercepted arc, for 34 degrees. Now we can try another one. Notice here, circle P, so that's the center, has a diameter FG. That's really important because we know it's half the circle. We want to find the value of x. That's my find. Okay, this is what I'm looking for right here. Again, this is on the circle, the vertex, so it's inscribed. So I know the relationship is that the measure of angle x in this case is equal to half of its arc. So what is its arc? Well, let's go ahead and turn its light on. There we go. And let's follow down each arm of the angle. This would be its intercepted arc. You'll notice, though, that is from one end of the diameter to the other. That's half the circle. Well, how much is the whole circle? 360. So this has to be 180 degrees. The other side would also be 180 degrees. And that's a key. When you see diameter, you know this cuts the circle in half. So that's something we're going to have to remember whenever we see a diameter built into the problem. So basically you're thinking 180 degrees, and that's what that is. So the measure of angle x then is equal to half of the 180. So the measure of angle x is equal to 90. And that's kind of cool. That's a 90-degree angle right there. Finally, if we go take a look at another challenge here, we're solving for x again. That's my find. So I'm not done until I have this x right there. Now, again, what kind of angle is this? Well, it's on. The vertex is on the circle, so this is inscribed angle. And we know that the measure of the angle is equal to the intercepted arc divided by 2. This is equal to its arc divided by 2. So you go ahead, you turn its light on. Here's its intercepted arc. So my angle happens to be 3x minus 3. My arc is 120, intercepted arc, and it's divided by 2. So I can reduce here. If I couldn't, I would just multiply both sides by 2. But in this case, I can reduce to 60, and it's just algebra at this point. Let me add 3 to both sides. Divide both sides by 3. X is equal to 21, and I'm done. If you're trying to remember the difference between a central angle and an inscribed angle, again, the central angle's vertex is at the center, inscribed is on the circle. And this central angle that would have been right here, look how much bigger that is than this one. This one down here is way more narrow, because if you pull it backwards, it has to narrow as it comes back. So this one has to be smaller. The inscribed is always smaller than the central angle that intercepts the same arc. So if this one's always smaller, and you already know this one here, these would be the same, and you know this one's smaller, that's how I remember that this one is going to be half of the arc. This one is always the same, the central. So the inscribed angle is half of this because it got smaller as I pulled it back than the central angle. Make sure you annotate and you'll be fine. Good luck.